Hi everybody, hope you are all doing well. I'm back again with a new lesson. On today's lesson, we're going to explain the moment of inertia for rotational motion. But before we get started the new lesson, I would like to remind you the previous lesson. Remember in the previous lesson, we talked about and we explained about the center of mass and center of the gravity of an object. The center of mass of an object is a point at which all the mass is concentrated during analyzing the translational motion. For example, if you throw a stick or hammer into the air, in that case, this stick or this bat has both types of rotational motion and translational motion. So the combination of the motion of this bat when it is throwing into the air is translational motion and rotational motion. The center mass of the stick and the bat is considered to be a point mass, okay, which is translating or which has a translational motion. The center of mass of the stick has translational motion or considered or treated as a translational motion. In the absence of the air resistance, the center of mass of the stick is tracing parabolic or moving in a parabolic motion. Okay, so as you know that parabolic motion is a translational motion because its position changes continuously. At the same time, the bat or the stick has rotational motion, but all points or the ends of the bat has or spin or has rotational motion when the bat is thrown into the air. Okay, but on today's lesson, we're going to explain, as I mentioned, the moment of inertia of an object. Okay, before starting explaining about the moment of inertia, I would like to remind you the inertia when you have learned it in a previous year, when you have learned it in the last year in grade 11. In grade 11, you have learned about the inertia, Newton's first law. Newton's first law says an object at rest remains at rest, an object in motion continues in motion when the net force acting on the object is zero. Okay, so the inertia is the same thing. For example, when an object has more mass, it means that this object has more inertia. Why? Because the inertia is the tendency of an object to resist in translational motion. More mass, more inertia prevents its state in rest or its state in motion. For example, when an object has more mass, it means that this object has more inertia. So you cannot move or you cannot pull or push this object with a small mass. It requires more mass. Okay, so that is why the heavier object prevents its state at rest. But in the case when you are using a large amount of force, in that case, this object starts moving. Okay, so in that case, when the object starts moving, it is difficult to stop this object. So that is why when the object is moving with the heavier mass, okay, with a huge mass, this object is very difficult to stop it. Why? Because this object prevents its state in motion, such as in the Newton's first law. Okay, but moment of inertia. So the conclusion of the inertia is the inertia is the resist or the tendency of resist translational motion. But moment of inertia, okay, in this year you will study the moment of inertia. At the end of this lesson, you will able about what is the difference between the moment of inertia and the inertia. Moment of inertia, the tendency of a body rotating about a fixed axis to resist what? Change in rotational motion. But inertia is resist in the change of the translational motion. Resist the change in what? In translational motion. But moment of inertia resist change in rotational motion. So moment of inertia measured in kilogram meters square. Moment of inertia is a scalar quantity and always has positive sign. Moment of inertia is a scalar quantity, can never be negative, it's always positive. Why? Because moment of inertia depends on mass and the radius and the distribution of the mass around the axis of rotation, which is the shape of the object. So the general equation of moment of inertia is what? mr squared, or you can say I is the symbol of what? Moment of inertia. This capital I is what? The symbol of moment of inertia. Is equal to the factors of the shape, because moment of inertia, it depends on the distribution of the mass around the axis of rotation. For example, the difference between the moment of inertia of the solid sphere and the ring, there is a difference between these two shapes. Why? Because the solid sphere, such as a bowling ball, all masses distributed around the axis of rotation or close to the axis of rotation. But for the ring or thin hoop, for the ring and thin hoop, all masses distributed at the rim or the edge of the ring. So that is why they are different in shapes, so they are different in moment of inertia. Okay? But all shapes, they have mass and are square. I is equal to what? The factor of the shape times mass times distance from the axis of rotation square. So, moment of inertia measured in what? Mass measured in what? Kilogram. Radius measured in what? Meter square. It becomes kilogram meter square. This is the unit of moment of inertia. And also it has equivalent unit. Inshallah, in the next lesson we will study in the section 3 about the Newton's second law for rotational motion. You will understand about this equation. This is another equation of moment of inertia. This equation, sorry, this unit, it came from what? From this equation. Torque is equal to what? I alpha. This is Newton's second law for rotational motion. In section 3 we will study in detail. Okay? What does the moment of inertia depend on? This question has been brought in 2014, term 2, in the second trial. What does moment of inertia depend on? I. The moment of inertia depends on the object's mass, object's shape, okay, and distribution of the mass around the axis of rotation. Okay, so the moment of inertia, it depends on these three factors. For example, which one has the largest moment of inertia, or which shape has the largest moment of inertia? Look at this, please. If you have an incline, okay, and this is solid sphere. Assume that this is solid sphere, such as a bowling ball. Okay, this is bowling ball, and for example, this is disc. Okay, so let's extend the incline. Sorry. Okay, and that. The first object is a solid sphere. What is this? This is solid sphere. Okay, the second one is solid disc, and the third one is hollow or hollow sphere. Sorry, this is hollow sphere, such as a basketball or football ball, and the last one is ring. Okay, what is this ring? Assume that all the shapes, they have the same mass, and all shapes, they have the same radius, but different what? Different shape. Okay, this is solid sphere, this is solid disc, hollow sphere, and thin hoop or ring, such as a bicycle tire. Okay, they have the same mass, all masses are equal. Okay, they have the same radius, but different what? Different shape and different what? Distribution of the mass around the axis of rotation. Which one has more close distribution of mass? The solid sphere. If, as you can see in this picture, the solid sphere, all masses of the solid sphere distributed evenly around the axis of rotation. The mass is very close to the axis of rotation. Okay, but here in the disc, also the mass is distributed evenly, but its shape is different. This is disc, and such as a compact disc, okay, or pulley, merry-go. This is the hollow sphere. Hollow sphere, such as a football ball or basketball. So inside the hollow sphere, there is air. Okay, the mass distributed around the edge of the object or hollow sphere. And this is ring, as you can see. What is this? This is ring. Okay, all masses are distributed at the edge or the rim of the object. So if you release all shapes, for example, assume that this is 30 degree with the same height. If you release all shapes with the same height at the same incline in a rough surface, be careful, this is rough surface, okay? Rough surface. Which shape wins this racing? Which shape wins this racing? So, of course, the solid sphere. The solid sphere came down at the incline at the first. Now I'm going to tell you why. So, which one wins the racing? The solid sphere. The solid sphere, the first time. The second time is the disc. The second one, the disc is a moving, okay? It becomes the second one. The third one is the hollow sphere. The hollow sphere. And the last one is the ring. Okay? So the ring is rotating very slow. Why? Because the ring's moment of inertia has the highest value, or the value of moment of inertia of the ring is bigger than the hollow sphere disc and the solid sphere. So that is why the angle, which one has highest angular speed, maximum angular speed? Solid sphere. The angular speed of the solid sphere is bigger than the angular speed for disc, and bigger than the angular speed of the disc is bigger than of the hollow sphere, such as basketball, and it's bigger than the angular speed of the ring. So that is why the solid sphere, it came at first. The second one, the disc. Okay? The third one, hollow sphere. The last one, ring. Why? Because the moment of inertia of solid less than moment of inertia of disc. And the moment of inertia of the disc is less than the moment of inertia of the hollow sphere, and less than moment of inertia of ring. So that because of the moment of inertia, difference of moment of inertia, that is why the objects do not moving with the same angular speed. Okay, so they are reaching with a different angular speed. So we can conclude that the moment of inertia is inversely proportional to what? To the angular speed. Okay? When does an object has more angular speed? If its moment of inertia is less. Less moment of inertia has what? More angular speed. Okay? So the moment of inertia of moment of inertia of solid is equal to 2 over 5 mr squared. This is for solid sphere. For what? For solid sphere, such as a bowling ball. Moment of inertia is equal to 1 over 2 mr squared. For what? This is for disc or merry-go or solid cylinder. Okay? Moment of inertia is equal to 2 over 3 mr squared. This is for hollow sphere. Hollow sphere, such as a football ball. Okay? Or volleyball ball. Okay? The last one for the ring is equal to what? mr squared. This is for what? For ring or thin hoop, okay? Or point mass. So if all shapes they have the same mass and same radius. All shapes they have the same mass, same radius. But different what? They have the same mass and radius, not shape. They have the different shapes and different distribution of mass around the axis of rotation. Which one is bigger? The ring. Ring has the largest value of moment of inertia. If you divide these two numbers, 2 over 5, it's going to be 0.4. This is 0.5. 0.66, this is 1. As you can see, the moment of inertia of the solid sphere is less than the moment of inertia of the disc and less than the moment of the inertia of the hollow sphere and the ring. Okay, which one has the lowest value of the moment of inertia? The solid sphere. So that is why the solid sphere, it came at first. It has maximum what? Maximum angular speed. Why? Because it has lowest value of moment of inertia. Why? Because moment of inertia is inversely proportional to the angular speed. Okay? Moment of inertia, the difference between moment of inertia and torque. Moment of inertia, it is the amount of the resistance of a body to any change in its rotational motion, the resist of the change in rotational motion. But torque, it is the ability of the force to rotate an object around some axis. Moment of inertia measured in kilogram meter square, but torque measured in Newton meter. Moment of inertia is always positive. Why? Because it depends on mass and radius. Mass and radius can never be negative. That is why moment of inertia is a scalar quantity. But torque can be positive and negative. Okay? In the case of the counterclockwise, torque becomes positive, in clockwise becomes negative. Moment of inertia depends on the object's mass, shape, and the distribution of mass around this, the axis of rotation. But torque depends on what? Force, lever arm, and the angle between force and the distance. Moment of inertia is inversely proportional to the angular speed. Okay? Greater moment of inertia has less rotation, less angular speed. But in the torque is directly proportional to the angular speed. Moment of inertia is equal to mr squared. This is general equation. Torque is equal to F d sine theta. What is the advantage of moment of inertia? It is a measure of the resistance of a body against what? Change in its rotational motion. Okay? So the moment of inertia is the resist of what? Change in rotational motion. But inertia, just inertia alone, inertia is the resist change in translational motion, not rotation. Okay? Here we have some shapes. So it is very important, be careful, because maybe in the Wizari exam you will see which of the following is the value of the moment of inertia, or which of the following equation is correct about the moment of inertia, for example, for the solid sphere, or for example, for the thin rod about perpendicular axis. Okay? For the first one, thin hoop or hollow cylinder about symmetry axis. What is this? This is thin hoop or hollow cylinder about a symmetry axis, such as a ring. When it is rotating, it is value of moment of inertia is equal to what? 1. I is equal to what? mr squared. 1 mr squared. Thin hoop about what? Symmetry axis. Okay? When the object is moving like that. Or when the ring is rotating like this is symmetry axis. It is moment of inertia is equal to what? 1 mr squared. The thin hoop about diameter, this is very important, be careful. Not every thin hoop has 1 mr squared for moment of inertia. Sometimes the thin hoop has 1 over 2 mr squared. Okay? So we can write like that. Thin hoop or ring, we have two cases. When the thin hoop is rolling about the symmetry axis, okay, about symmetry axis, it is moment of inertia is equal to what? mr squared, 1 mr squared, okay? But about diameter, it is moment of inertia, it's gonna be 1 over 2 mr squared. Be careful, okay? When a ring is rotating about diameter, okay? As you can see in this picture. Point mass about axis also has mr squared value. The point mass, such as when the object is moving in a circular path, Okay. Now I'm going to show you. Sorry. Just wait. Okay, I found it. When we say the point mass, it means that when the object is moving in a circular path, this object considered to be a point mass. What is the moment of inertia for this ball when it is tightened at the end of the string or fixed at the end of the string? This ball has moment of inertia, and if this moment of inertia is equal to 1 mr squared, such as a thin hoop, okay? So the moment of inertia of a point mass, such as a ball, when it is fixed at the end of the string and it's being wheeled in a circular path, in that case, it is moment of inertia is equal to what? 1 mr squared. Disc or solid cylinder about symmetry axis, it is moment of inertia 1/2. Okay, so this two shape is very important. Be careful and pay attention, please. This is about the stick or rod. Thin rod, such as a bat or stick, about perpendicular axis through the center. Okay, so we have two types of rod. The first one, about perpendicular axis, through the center, So let's draw the bat or rod. This is rod, and this is the axis of rotation. Okay, the axis of rotation located at where? The center. In that case, the distance from to the axis of rotation is less, okay, comparing with the end of the rod. In that case, the moment of inertia is equal to what? Is equal to 1/12 ml squared. L or R is the same because the rod has length, so that is why we have to write down L, okay? So when does the rod has 1/12 ml squared? When the axis of rotation is located at where? At the middle. So in that case, R is less. So the angular speed, when the axis of rotation of the rod is located at the center, we have less distance from axis of rotation. This radius with the moment of inertia is directly proportional. Less R has less moment of inertia, but more angular speed. So which one is easier to rotate? If you catch the rod at the middle of the rod or at the end? Absolutely at the middle. Okay. For example, if you hold the bat or the stick or rod at the middle, okay, it means that the axis of rotation is located at the middle, so you can rotate the bat or the rod easy. Okay, it has more angular speed. But so in that case, moment of inertia has 1/12 ml squared. But in the second case, less R, less moment inertia, but more angular speed. What do you mean by more angular speed? It means that it's easy to rotate. Okay, so the second case, about the second shape, thin rod about the perpendicular axis through end. About what? Perpendicular axis through what? Through end. Be careful. This is through the center, but here through the end. So in that case, let's draw the bat. But its axis of rotation is located at the end of the bat. Okay? What is this? This is axis, and also this is axis of rotation. In that case, we have more distance from axis of rotation, more radius, more length, and It provides more moment of inertia, but less angular speed. Less angular speed has more moment of inertia. More moment of inertia, I is equal to what? 1 over 3 ml squared or r squared. Okay, so when does the bat has the value 1 over 3 ml squared? If the axis of rotation is located at the end, or when you say when the thin rod about perpendicular axis through the end. When does the moment of inertia is equal to 1 over 12 ml squared? When the rod is the thin rod about perpendicular axis through the center. Okay, this is the solid. We don't have solving question about the rod about perpendicular and about the perpendicular axis through the center or through the end, but it is very important for the student in grade 12 to know the value of moment of inertia, maybe, and also it has been brought in the general exam, Missouri exam, which of the following equation is correct for the thin rod about perpendicular axis through the center? Which one is correct? 1 over 12. Which of the following equation is correct about the thin rod about perpendicular axis through the end? 1 over 3 is correct. The solid sphere, as you can see in this picture, is 2 over 5 mr squared. And the hollow sphere, or the thin hollow sphere about the diameter, is 2 over 3 mr squared. So these are the value of moment of inertia, and it is very important. We have a solving question for the thin hoop, solid disc, solid sphere, and hollow sphere. It is very important, and pay close attention. You have to memorize all the value for the all different shapes. Okay. As you can see, I mentioned again, this is the shapes. Okay, so it will be very helpful for the students to see the shapes. To find the value of moment of inertia, use the following relation. Moment of inertia is equal to mr squared for what? 1 mr squared. For the thin hoop, such as ring, hollow cylinder about symmetry axis, and point mass. Okay, this is hollow cylinder, such as a can of Pepsi or Cola, and this is ring, this is point mass. Okay, for these three shapes, moment of inertia is equal to 1 mr squared. The second one, when does moment of inertia, and for each of the following shapes, the moment of inertia is equal to 1 over 2 mr squared. For the solid disc, such as the compact disc, okay, and you have seen absolutely. And for the solid cylinder, this is solid cylinder, such as the empty can, okay, and or the thin hoop about diameter. Thin hoop about diameter has a value of what? 1 over 2 mr squared, as I mentioned in a previous slide. Okay. The third one, I is equal to 2 over 3 mr squared. This is for what? This is for the thin spherical shell or thin hollow sphere, such as a football ball or volleyball or any ball that has not mass inside it. Okay. So in that case, the mass distributed evenly around the rim of the object. It is empty. Okay. And for this one, I is equal to 2 over 5 mr squared. This is for the solid spheres, such as a bowling ball or the all planets. The Earth's planet has moment of inertia 2 over 5 mr squared. But be careful and pay close attention, please. I'm going to ask you, okay? What is the value of moment of inertia of a bowling ball? Be careful. Bowling ball. When the bowling ball or solid sphere is attached at the end of the string and being reeled in a circular path. For example, what is this? Assume that this is the bowling ball. If the bowling ball is releasing or rolling from an incline when it is rotating, its value of moment of inertia is equal to 2 over 5. The moment of inertia of a solid sphere is equal to 2 over 5 mr squared in the case when the solid sphere is rolling down from an incline or rolling on a flat circle or on the flat roll. But in the case when the bowling ball is being attached at the end of the string and reeled in a circular path, what is the value of moment of inertia in that case? In that case, the moment of inertia of the bowling ball is going to be 1. Why? Because when the bowling ball is attached at the end of the string and being reeled in a circular path, so in this case, the bowling ball considered to be a point mass. So you know that the point mass has a moment of inertia 1 mr squared. In the case, for example, when the solid cylinder, when the ring, or when the rod or the solid sphere is attached at the end of the string and moving in a circular path, we have to treat with this object as a point mass, and its moment of inertia is equal to 1 mr squared. Okay? So it doesn't necessary for the bowling ball or the solid sphere to has 2/5 mr squared always. It depends. When the solid sphere has value I is equal to 2/5 mr squared, when it is rolling. But when you fix it at the end of the string, it becomes what? Point mass, as you can see in this figure. Okay? The thin rod we studied about axis through the center, its moment of inertia is equal to 1/12, but axis through the end, its moment of inertia is equal to 1/3 mr squared. An object can be rotated around a variety of axes. However, rotating an item or an object around some axis is easier than the other. Every point has its axis of rotation. Okay? With the other rotation, its rotation is not going to be easy. It's going to be difficult. Mass is an intrinsic property of an object, depends on the number of particles, okay, and it doesn't change by changing location. Okay, a mass is constant, it depends on the number of particles, intrinsic property of an object. While the moment of inertia depends, object is mass, the distribution of the mass around the axis of rotation is very important, be careful. This is the difference between mass and moment of inertia. Mass depends on the intrinsic property as it depends on the number of particles. But moment of inertia, it depends on the object's mass and the distribution of mass around the axis of rotation. The smaller the moment of inertia, less moment of inertia, easy to rotate, and easier the rotation of the object, and vice versa. Okay, because it is inversely related to each other. The farther the mass of an object from the axis of rotation, the greater is the object's moment of inertia, and more difficult to it is rotate the object. This is why in the race along the inclined plane, as you can see in this picture, which one wins? The solid sphere wins at first. Okay, because the mass distributed evenly through the axis of rotation and close to the axis of rotation. Look, why in the race along the inclined plane, the solid sphere, solid cylinder, and hollow cylinder, the solid sphere came in the first. Why? What is the reason? Because of the moment of inertia. The moment of inertia has the lowest value for the solid sphere. Has less inertia. Less moment of inertia. The solid sphere has less moment of inertia, but it has more angular speed. And the hollow cylinder came in the last. Even all objects have the same mass and same radius, and that they all start from rest because the mass. What is the reason? The reason is here. Because mass of a solid sphere is more evenly distributed through its volume. Okay, so that is why it has small moment of inertia. While the mass of the hollow cylinder is all concentrated around it is what? It is ring or edge. Larger moment of inertia. Moment of inertia from large to small, ring, holy ball, disc, cylinder, solid sphere. Okay? The distance of mass, from the axis of rotation is very important in determining the moment of inertia. I'm going to repeat, please. Listen carefully. The distance of mass from the axis of rotation is very important in determining the moment of inertia for the shape. At a given radius from an axis, it doesn't matter how the mass is distributed around the axis. Okay, for example, such as a ball on a string has the same moment of inertia as the thin hoop. If the distance of the point mass from its axis of rotation is equal to the hoop. For example, if you have a ball, okay, fix it at the end of the string, this is R, and it's being reeled in a circular path, okay? This is treated as a point mass. Its moment of inertia is equal to what? mr squared or 1 mr squared. So this object has the same moment of inertia of the ring. Okay? If the mass and the radius, if the mass of the ball is equal to the mass of the ring, and the radius of the ball, the distance of the string, is equal to the radius of the ring. So in these two cases, ball fixed at the end of the string and reeled in a circular path, or the ring is rolling through the flat road, which one has more moment of inertia? If the ring and the ball, they have the same radius, okay, the distance of the string is equal to the radius of the ring, and the mass of the ball is equal to the mass of the ring. They have the same mass, same R, so moment of inertia of ball is equal to moment of inertia of the ring. They have the same moment of inertia. Okay, so that is why it doesn't matter how the mass distributed around the axis of rotation, but it depends on the distance from the axis of rotation and also the mass of the object. For example, look at this question: a solid sphere. Okay, don't say anytime when you see the solid sphere you have to write down 2/5. No, this is not correct. Be careful. You're going to make a mistake in that case. Be careful and listen carefully, please. A solid sphere is fastened or fixed to the end of the rod and turned in a horizontal circle by someone. What is the solid's moment of inertia? Equivalent to what? 1 mr second. Why? Because the solid sphere is fastened to the end of the rod. We have to treat with the solid sphere in that case as a point mass. The value of moment of inertia for the point mass is equal to 1 mr squared, not 2/5. Please, don't choose or don't select it A. A is wrong. B is correct. But when the question says, which of the following is correct for the bowling ball when it is rolling through an incline or through the flat road? In that case, when the bowling is rolling, solid sphere is rolling above the diameter, in that case, moment of inertia is equal to 2/5. Okay, if the surface is smooth, this is very important, pay attention, please. If the surface is smooth, okay, for the smooth surface, solid sphere, such as a bowling ball, disc, hollow sphere, and ring. In a smooth surface, if we release all differential, if they have the same mass and the same radius with the same height, if we release on a smooth surface, which shape wind is racing? All shapes, they reaches at the bottom of the incline at the same time. Okay, all shapes reaches at the bottom of the incline at the same time, at the same rate. Why? Because in a smooth surface, the object doesn't rotate. On a smooth surface, the object doesn't rotate. When the object is not rotating, so in that case, the object considered to be a point mass. For the point mass, according to Newton's law, all objects, they reaches at the bottom of the incline at the same time, at the same rate. For example, if you release a bowling ball with a heavier mass and a feather with a lighter mass at some height, in the absence of air resistance, listen carefully, please. In the absence of air resistance, if there is no particle in the vacuum chamber, if we release at 20-meter height, for example, the bowling ball and the feather, which one lands at first, or which one come at first, or which one wins? The answer is, you have to say both of the bowling ball and the feather at the absence of air resistance, they reaches the ground, or they will land at the same time exactly at the same rate. Why? Because the gravity is the same for all objects. Okay, regardless to their mass and shapes. Okay, so as I explained in chapter 1 section 3, what does free fall acceleration depends on? It depends on the constant universe and mass of the planet and the distance or the radius of the planet, the square radius of the planet. Gravity doesn't depending on the mass, shape, and radius. So that is why all shapes came at the same time, at the same rate. Okay? Because they have the same speed. In the absence of what? Friction and air resistance. All shapes, they reaches at the bottom of the incline at the same speed. So you can finding the speed is equal to radical 2gh. All shapes, they have the same height and already the gravity is constant. So when does all shapes, they are moving downward with the same angular speed or with the same tangential speed or with the same velocity? In the case when the surface is a smooth surface, not rough surface. Okay? But in the case of the rough surface, which one wins? The solid cylinder wins this racing. The second one, solid disc. The third one, hollow sphere. The last one, ring. Okay? If the surface is smooth, the objects do not rotate. They only move in a linear motion, translational motion, or in the absence of friction, the acceleration due to the gravity is the same for all objects near the Earth's surface. The similar properties between moment of inertia and mass. There is a difference. The difference between mass and moment of inertia, mass measured in kilogram, but moment of inertia measured in kilogram meters squared. Mass resists the translational motion, change in translational motion, but moment of inertia resists the change in rotational motion. This is the difference between moment of inertia and the inertia. But the similarity between mass and moment of inertia, both of them, inertia resists the change in translational motion. The similar property between moment of inertia and mass is both of them resist change in motion. But the difference between mass and moment of inertia, the inertia resists change in translation, moment of inertia resists change in rotation. Mass depends on the intrinsic property of the object, moment of inertia depends on the object's mass, object's shape, distribution of the mass around the axis of rotation. Mass measured in kilogram, moment of inertia measured in kilogram meters squared. What is the effect of the distribution of mass on the axis of rotation, on the moment of inertia? It is very important. The distribution of the mass is very important for the moment of inertia. More mass close to the axis of rotation has less moment of inertia. When the mass is away from the axis of rotation, such as a ring, has more moment of inertia and less angular speed. How many shapes do we have? As we can see in this figure, we have two shapes. Same radius, same mass. But different what? Different shape. Why? Because the mass distributed evenly through the disc, through the center of, through the axis of rotation for this disc. But for this ring, mass distributed around the rim of the edge of the ring. So that is why, which one has more moment of inertia? Ring has more moment of inertia, but less angular speed. But disc has less moment of inertia, more angular speed. So that is why it is win in this racing when we release from the incline. Okay, the closer the mass is to the axis of rotation, the less the moment of inertia and easier the rotation of the object. When body's moment of inertia is low, it can stop quickly and easily. If a body has a big moment of inertia or more moment of inertia, it's difficult to spin and stop. At a tighter, closer distribution of a mass along the axis of rotation will result what? Smaller moment of inertia, but larger angular speed such as in a bowling ball. When a baseball player holds the bat at its length, when the baseball holds the bat at the ends, it has more distance from the axis of rotation. More R, which means that more moment of inertia, but less angular speed. So it is difficult to swing the bat when the players holds or catches the bat at the end of the bat. Okay. In that case, it has more moment of inertia, less angular speed. So that is why when a baseball player holds the bat at its length, what happens? Its length becomes greatest. Its length becomes what? R or L becomes greatest. And moment of inertia is directly proportional. More angular speed decreases with respect to the rotational axis. So it is moment of inertia becomes greatest and it is difficult to rotate. Why? Because it has less angular speed. So that is why do the baseball players hold the bat near the center. Why near the center? To decrease what? Usually the players hold or catch the bat near the axis of rotation, okay? To decrease what? To decrease L. When L decreases, what happens to the moment of inertia? Also decreases. What happens to the angular speed? Increases. So the swinging becomes more and it has more angular acceleration and produces more tangential acceleration. Okay? We have some questions which is related with the moment of inertia. Two children are rolling automobile tires down a hill. One child claims that the tire, or he thinks that the tire will roll faster if one of them curls up in the tire center. Okay? The other child claims that this will cause the tire roll more slowly. Which child is correct? Let's draw a figure. Okay? Assume that there is a hill, incline. Okay? So we have two children with the two tires. And this is tire number 2. Okay. In the first case, the child is curled up inside the tire. But the second tire, they have the same tire, same radius, same mass. Okay. But one of the tire is the child is curled up inside the tire. So which one wins if you release both the tire at the same time at the same rate? In that case, in the first tire and the second, the first tire came at first, okay? Or the first tire win this racing. Why? Because in the first tire, the tire number 1, when the child was curled up inside the tire, it has more mass and more inertia, okay? I is equal to what? This is ring mr squared. This is the distribution of mass and this is the mass. When the child is curled up into the tire, mass increases, moment inertia increases. But at the same time, this child, when curled up inside this tire, its mass is close to the axis of rotation. So it means that radius decreases. When the radius decreases, moment of inertia also decreases. So which one has more effective? Distribution of mass or mass? The distribution of mass has more effective. The radius of the object has more effective. Why? Because it is squared. So that is why the tire with the child curled up win this racing and it come down at the first. Okay? So the tire would roll faster with the child curled up inside because has less moment of inertia. Because the child distributed all the masses around the axis of rotation. In that case, the mass is close to the axis of rotation, it goes to decreasing the moment of inertia. So the moment of inertia can never be larger than 1. Why? Because for the ring, we cannot distribute mass farther and more farther from the ring. Okay? So that is why the moment of inertia can never be larger than 1. The moment of inertia for the regular shape object can never be larger than 1 mr squared. Okay? Where m is mass and r is the radius or the size of the object. Why is this so? Which object a moment of inertia is equal to mr squared? For the I is equal to mr squared, such as ring, okay? All the masses of the ring distributed around at the farthest point. We cannot distribute this mass more and more because the ring is going to be break. Okay, the mass of the objects is all distributed farthest from the axis of the rotation, like the hoop or point mass around the axis and axis. Question 7. It is more difficult to do sit-up with your hands held behind your head than doing a sit-up with your arms stretched out in the front of you. Okay, so the people who are taking the exercise in the gym or in a fitness, to doing the exercising for the muscles to become stronger, so they do like that. Okay, they sit up when the hand is held behind her head, the head. So in that case, more mass away from the axis of rotation. It means that the radius increases, moment of inertia increases, angular speed decreases, and it is difficult to set up. Okay, so that is why when your hands held behind your head, it is difficult to become sit up. Why? Because angular speed is less. Because your mass is distributed farther from the axis of rotation. Okay. For example, if your hand is held behind your head, this is axis of rotation. Okay. So mass away from axis of rotation, it means that R increases. When R increases, moment of inertia increases and angular speed decreases. It is difficult to sit up. Okay? But in the case when someone stretches his arms, look, through the axis of rotation, so the mass is close to the axis of rotation. Okay? It means that less R has less moment of inertia and it has more angular speed. It is easy to sit up. Okay? So the moment of inertia is increasing and its rotating will be difficult. Question 10. At a circus performance, juggler. Very good question, please be careful. At a circus performance, as a juggler is throwing 2 spinning clubs. How many clubs? 2 clubs. Okay? One of the club is heavier, has more mass than the other. Which of the following statement is true? The smaller club, it means that less mass. Likely to have larger moment of inertia? No. Why? Because moment of inertia is equal to mr squared. Less mass, less moment of inertia. So that is why A is incorrect. Because the smaller club is likely to have large? No. Smaller club is likely to have smaller moment of inertia, not larger. That is why A is wrong. The second one, the ends of each club will trace out of parabola. The ends? No. The ends rotate. Okay? B is also incorrect. So, as I explained it in a previous lesson, when the club or when the thin rod is throwing into the air, the ends spinning or rotating, not tracing parabolic translation. But it is point mass, it is center of mass, is tracing parabolic or moving in a translational motion. Let's continue. C, the center of mass of the club, of each club, will trace center of mass. Be careful. Center of mass. Will trace parabola? Yes. C is correct. And also I added another choice. The movement of the ends has a rotational motion or spins? Yes. Okay? This is question 10. Question 11 related with the question 10. Listen carefully, please. When the juggler in the previous problem, in question 10, stands up straight and holds each club, okay, at arm's length, where with his center of mass, okay? Assume that we have 2 clubs, the heavier club and the lighter club, okay? When the juggler stands up and holds this, strengthened all the 2 clubs, okay? In a previous lesson, the juggler stands up and straight and holds each club at arm's length. Arm's length. The heavier side, the lighter side. Without club. Where is my axis of rotation, center of mass? The center of mass for my body is located at the middle. Okay, in that case. But if I hold 2 clubs with a different mass, heavier club and lighter club. Now, where does the location of my axis of rotation? Near the heavier side or near the lighter side? Absolutely, it's located at the near the heavier side. Okay, as you know that for the irregular shaped objects such as a hammer, it is balancing point or axis of rotation. Center of mass is located near the heavier side, not the lighter side. Or you can say the center of mass for the irregular shape is located away from the lighter side. Let's read which one is correct. Located, where would his center of mass? We have to find the center of mass. Located at point exactly in the middle? No. Why? Because he holds the two clubs with his extent with the arm's length. B, slightly or close to the side where he's holding the light club? No. Slightly or close to the side where he's holding the heavy club? Yes, of course. Be careful. C is correct. Very good question. Pay attention, please. This is a Wizari question. It has been brought many times. Slightly to the side where he's holding the heavy club. Or you can say farther from the side where he's holding the light club. Okay? Question 29. We're going to solve this question in section 3 also. But in this question, a solid ball, 2 kilograms. Radius 0.5 meters, starts at a height 3 meters and rolls down 20 degree slope. A solid disc and a ring start at the same time and the same height. What is the second shape, second object? Solid disc and ring. Now, how many shapes do we have? 3. Okay? Solid sphere, solid disc, and ring. Which one wins? Solid sphere. Why? Because its moment of inertia is equal to 0.4 mr squared. The second one, solid disc win. Why? Because it is equal to 0.5 moment of inertia. The ring came at the last time. Why? Because its moment of inertia is equal to 1, has the largest moment of inertia. So the solid ball reaches at the bottom faster than the others when they're racing, because solid ball's moment of inertia is less than the solid disc and the ring. Okay? So that's all for today. Hope you get benefited, and please keep up your best doing and keep up your hard work. And inshallah, in the next lesson, we're going to explain, and we will explain the rotational equilibrium and translational equilibrium, the two conditions of the equilibrium. And we're going to solve the questions related with the translational equilibrium and rotational equilibrium. Have a good time.